sort of mentioned, highlighted having solid state hard drive as a big requirement. So give me a thumbs up if you've got a solid state hard drive or have access to a solid state hard drive or is planning to buy a solid state hard drive. Okay, not yet for Jack, but these guys have it. Jack's getting it, planning to get it from Brittany, buying one, not yet, and buy one if I need space. So you've got one, Nathan. You just need to get one if you need space. Is that correct? Yeah. All right. So for those of you, yeah. So for those of you, before you go out and rush and get a solid state hard drive, so just I noticed Vina. I'm really talking to these because they're doing the 4 IVMs. So right now in this discussion, if you want to mute our sound, it's okay because I know you're working on something else. So if you like, you can mute us and you can go on with your other work while I talk to these guys, because I know you know this stuff already. So it's up to you though. You can definitely tune in. So for those of you looking into getting a solid state hard drive, let's actually be smart about it. Okay, obviously I'm assuming that all of you have limitations on how much money you've got. You're not independently wealthy and can spend whatever money you like, but so therefore you want to get the best bang out of your buck. Okay, so what we need to understand is why we need the solid state hard drive and what we're looking for in a solid state hard drive, not just the idea of a solid state hard drive. So basically, now that you know a bit about virtualization, you know that when we create a virtual machine, they're running inside of our physical machine, on top of our physical machine, inside the host operating system. And the virtual machine is what we call the guest. So basically, if we have 3 or 4 virtual machines running at the same time, I've got my domain controller there. Let's turn on this Windows 10. Let's turn on this Windows 8. And basically, they're all running on my laptop at home. So they're all sharing essentially this hardware. That's my laptop. But the problem is, this laptop hardware cannot cope with the demands of all these free Power 1, 2, and 3 virtual machines right now. Can it actually cope with the demands that's from all these free computers effectively? The hardware was designed to work with one computer, really, one operating system. Can it cope with the demands of it from all these computers? So you can see that my CPU's gone up. That's not a huge deal. It's just all starting up, and they'll drop down soon when my machines become less busy. You can see my memory's gone up. So that's what we're talking about. We need 16 gigs of RAM, because we know that every time we create a virtual machine, we give the virtual machine a certain amount of RAM. And obviously, the more physical RAM that's on our physical machine that we have, the more we can give to the virtual machines, and the more virtual machines we can have running at the same time. I've got 3. I can easily start up a few more, because you can see that I've only reached half capacity right now. Okay, and that's half capacity, and that's basically my physical machine, the operating system, which is installed directly onto that physical hardware, and then the virtual machines and their the operating system are installed onto those virtual machines, all sharing this memory. Okay, I've got 32 gigs here, which allows me to start up a few more. I've got a couple of hard drives here as well. One's a removable hard drive. This is a SSD, and you can see it's reading and writing as you expect. But really, the actual measure that's important with us is that our virtual machines a lot of the time is not doing a lot of work. Okay, it's not a production virtual machine. It's in the learning environment, so it's not doing very much most of the time. So the CPU and the RAM, as long as you got enough RAM to be able to start these virtual machines, each virtual machine doesn't need a huge amount, probably 2 gigs on average per virtual machine. Then our CPU is not going to be very busy, because as you saw, it's busy now because it's loading up. All these virtual machines are loading up, but it will soon drop away. But the hard drive is where it's going to be busy. Not so much it's reading massive amounts of files or not, because it doesn't read or write massive amounts of files, because it does not. We're using it again in a teaching environment rather than a production environment. I'll answer that question in a second, Brock. So if I start up another program, which is called Resource Monitor, the measure that's most important when I look at virtualization is this queue length. Okay, disk queue length. And if you've ever heard of the term queue, it's basically a lineup. It's like all of us, if we all went to the McDonald's all at the same time and there's just one person serving, we would all have to line up and order our food one at a time. And you can imagine that for the person at the end of the queue, the last person in the queue, it's going to be a while before their order is going to be placed. But if you think about it, that if they actually put on a few more staff, as in they put on a couple of more staff, as in they'll have 4 instead of 1, you can see that how our line can be served a lot faster. Okay, and in IT, in hard drives, this is what's called an IOs per second metric. IO per second. Okay, so let's have a look at what IO per second is. So if I actually IOPS, you might have heard of that term. So you might be able to buy portable SSDs. So you might see the Samsung T5 SSD. And if you look at it, they're these things, okay? Not to put anyone on the spot, does anyone have one of these? Or is anyone thinking of getting one of these for our studies here? You got 2. Well, they're not bad. They're a lot better than mechanical hard drives. But let's actually do a bit of research, okay? All right, so if we actually did that search, instead of actually doing whatever, it will do the IOPS, which is the metric. All right, let's have a look at this. So this is just the one I pulled out of just the first link on the list. I'm going to do a search for IOPS. So if we look at this this one, you can see that well, the biggest number are these two, read and write. Okay, so it's about 36,000 IOPS or 117,000. And what that means is that there's 36,000 input-output operations it can perform while reading, and 117 IOPS input-output operations when writing. Okay, let's keep that in mind. Let's do another search. So now we're comparing that with still Samsung, isn't it? So Samsung with Samsung, it's not necessarily a different brand, and this is a more like an internal hard drive. Okay, so this is a NVMe, so which is the user the M.2, which is a faster interface, but you can also get SATA ones, so 850. And these are more like your laptop hard drives and whatnot. But so the NVMe are probably the newer ones, and they probably have better performance. But let's even forget about those ones. Let's just look at these ones. Oops. Let's go all, and let's have a look at this storage review as well. So still Samsung. It's just a different type of hard drive. It's not sold as a all-in-one, ready-to-go external hard drive. And if we actually look for that IOPS, you can see that with here, we're talking about 98,000, 90-something thousand IO per second. And that's read. So if you compare that to this 30-something thousand, you can see that there's a difference, isn't there? So I'm not reading the chat. So basically, yeah. So some of you guys are already aware of that. So they're both Samsung products, but one is at 36,000 IOs per second, and one is at what's it, 98,000, 97,000, 94,000. It doesn't matter which one, but they're fairly close anyway. But you can see that that's almost 3 times the read speed, read IOs per second. So the question is, what if you did want an external hard drive? You can't. If you want an external hard drive, it makes sense to go get this off the shelf. It's ready to go. But you know what? I'm not saying this is a website that I'm going to use, or this is a company I'm going to use. I'm just saying this is where I get my price list, so that I can see what the price is. Okay, so if we actually have a look at what we've got here, so these are the M.2 NVMe solid state hard drives. If the way you read this, let's have a look at the Samsung, for example. So you've got 250 gig, 500 gig, 1 terabyte, 2 terabyte. Effectively, that is, I think it's here. This is going to be the price for the 250 or 500, and this is the 1 terabyte, and this is for the 2 terabyte price. So again, if you look at this, that's fairly expensive. For this one, for example, the Pro, for $500. But like I said, the 850 is not available, so that was an older one. There's the A60 Pro versus the Evo. Again, for let's say 1 terabyte, that is $238. Okay, for 500 gigs, 138. But you're probably asking me the question: how did I turn that into an external hard drive? Enclosure. All right, so enclosure. Here it is. All right, so if we look at this, this is the 2.5 inch. So basically, they're the ones for this type of hard drive. These are laptop type hard drives. They're 2.5 inch. And if you get one of these, I'm not saying which one to get. Just have a look at them. There's some which are better than others. Some cost more than others, but they're all average about the $30, $40 mark. And what you basically get, let's have a look at it, see if we can get a picture. Let's just get this one. And we'll do a bit of a search for it. And let's have a look at the image. There it is. It opens up like that. And basically you get your internal hard drive, you plug it in to the SATA port, you close the thing, and you've suddenly got a external solid state hard drive. Okay, so some of you will be able to mount these into your physical computers, whether that be your laptop or your desktop. Some of you may not be able to, and having it as a portable USB solid state hard drive works as well. So by having a solid state hard drive means we can run multiple virtual machines directly from the same hard drive at the same time. A bit like what I'm doing here with the 1, 2, 3 virtual machines with a server and 2 workstation computers. Okay, so that's why we need to understand why we need a solid-state hard drive. I think there was a question about cores previously. I think someone asked about how many cores would you allocate to your virtual machines. Well, the answer is not straightforward because the answer is it depends. If I actually look at my computer, if I look at my CPU, you can see that I've got CPU 0 all the way up to CPU 7, which means it's got 8 cores. Okay, that's 8 physical cores. Sorry, not 4 cores, but with hyperthreading, it gives me effectively 8 cores. So that means I can give my virtual machines up to 8 cores as well. So you might have remembered from creating a virtual machine this morning, you might have created a new virtual machine and you might have chosen custom. Don't worry about this for now. And let's not worry about that. Let's create that. And then this is the question you were asking about. How many cores do I get? So the key thing is the number of total cores here. So I can give 8 CPUs and 1 core each. And that's it's saying the virtual machines might not run public because it's configured to use more virtual processors than the actual sockets. Or maybe let's stick with 4. Or I can adjust this with 1 CPU and 8 cores. It's not going to make my virtual machines run faster or slower by changing the number of cores to extent, because effectively it's just showing, it's just exposing our operating system to how many cores it's got. Okay, meaning that the virtual machine, the operating system will see these cores. The problem with allocating all 8 cores right now, that's how many I've got, is that it means that in order for this virtual machine to have a turn on the physical CPU, so it's almost like, you know, you're waiting in line at the playground, you want to turn on the swings, but there's 8 swings, and you and your group of 7 friends, you and the 7 friends or 8 of you, will all go at once. That's what you're saying right here. What you're saying is, me and my friends all want to go on these swings at the same time. What does that mean? If you're at the playground, there's only 8 swings. It means you have to wait for every one of those swings to be available in order for you guys to have a go together. So you probably, in your heads right now, you're probably thinking, well, that's not very likely. If it's a busy playground, it's almost certain that this one or more swings will be used at any one time. So therefore, having 8 cores on my system with which only has 8 cores with hyperthreading, means that it's actually going to lose. It's going to be slower because it's going to be waiting to get its turn. So on my system, I will probably go maximum 4 cores. It's basically having 4 cores available at any one time. It's a lot easier to get 4 free out of an 8-core system or a system with 8 than waiting for 8. Think of going to a restaurant. It's easier to get a table for 1 or 2 than a table for 10 if it's a busy restaurant. So with the answer to your question, you know, it depends on what you want to do with your virtual machine. If it's just a simple virtual machine, if this was that Windows 10 virtual machine I was talking about, it's just it might just be a client. I don't need too many cores. I could just get away with 1. If it was a server virtual machine, let's say this server virtual machine was configured to be a System Center configuration manager with distribution points and whatnot, and it's going to be doing a bit of work, some of the programs that's written for these computers now will take advantage of the multi-core nature of the new hardware, so they are written to be optimized for more than 1 core. So in that situation, you might want to up this to 4 cores or something like that. But that's really something we don't have to super worry about right now. That's probably something that's going to come up in the future, though. Okay, so Brock seems to have a good handle on the hard drives he's looking at. Let's say, okay, so if you allocate 4 cores to 3 virtual machines, no, you wouldn't, because it's basically each machine has 4 cores. So each machine is waiting for your CPUs cores of your CPU to be freed before it can have its turn. They're not going to add up to 12 cores at the same time, if that's what you're wondering. You still only have 8 cores. It's just that they all have to wait for each other to have a turn for their 4 friends. Okay, they don't run at the same time because there's not that amount of physical cores. Okay, so you don't have to worry about that. It's not the same as RAM. RAM is because of RAM, you're using it or you're not using it. Whereas CPU, even if you're not using it, the cycles are just ticking through anyway. Okay, if you are using it, you're waiting for your turn, and you have access to whatever amount of cores are free at that time. If you can have your turn, then you'll have your turn. If you can't, then you keep on waiting. So like I said, if you have too many cores to your virtual machines, you might be waiting a lot longer than if you had less cores to your systems. All right, so hopefully everyone has a sort of a idea of why we need a solid-state hard drive, and maybe a bit of idea on what to look for. So if I were you, I would, if it's your money, make sure you spend it wisely. Do a bit of research, work out which one is the best bang for your buck based on, obviously capacity and speed, and the IOs per second, which is the most important thing for us as far as virtualization goes.